Hello, welcome to my channel. So today we are going to talk about superconductivity of metals in quantum computing. So let's get started. So my name is Ayush Kumar. My USN is 23 CS 1600 from first semester from the Department of Computer Science Engineering. My section is Audi and my subject is applied physics. So today's topic is superconductivity of metals in the quantum computing. So, superconductivity, what do you understand by the word superconductivity? So, let me explain it to you. So, now imagine like superconductivity as a magical highway where cars are basically electrons which can go without any resistance on a highway, creating a super efficient path for electricity. So, superconductors allow electricity to flow through it, make without any resistance, making them very efficient. So next we have quantum computing. What do you understand by the word quantum computing? So let me break it down to you. So quantum computing, you can take it as like a classical computer as super fast librarians who can check one book at a time to get your information. Now meet quantum computers. What they can do is basically they're like magical librarians who can check every book in the library simultaneously to get your information thanks to again quantum qubits. It's like doing a trillion calculation at once without any complications, making them potential speedster for certain types of problems. So now, what do you understand by the word superconduction of metals? So it is basically quantum computing because it enables the creation of superconducting qubits, which are basic units of quantum information. So next we have superconduction of qubits. So what do you understand by the word superconduction of qubits? So it is basically like, let me explain it to you. So superconducting qubits like tiny acrobats doing flips. These qubits are special because they can perform quantum tricks without losing energy, just like acrobats, moving flawlessly through a routine. So, this helps maintain the delicate quantum information needed for quantum computing without the usual hiccups, making them valuable players in the quantum circle. So, a quantum qubit is basically an artificial atom that can exist in two states, which is either a quantum 0 or a quantum 1, or you can say qubit 0 or qubit 1, or a superposition of both. Superposition is basically either a 0 or like a qubit 0 or a qubit 1 or both. So, a superconducting qubit is made up of superconducting circuit that consists of a capacitor and inductor, which basically is found in resonant LC circuit, which you have already learnt. So next, what does a capacitor do? A capacitor is basically like a stores electrical charges, while the inductor stores magnetic flux. The interaction between them, like charge and flux, creates a quantum harmonic oscillator. So next we have like which which also can be like manipulated by applying microwave pulse. So you would think like, what are microwave pulse? So let me explain it to you. Microwave pulse is like a quick burst of energy in the form of microwaves in the world of quantum computing. These pulses are used to manipulate and control qubits. That's why a microwave pulse is used. Types of superconducting qubits. So there are usually many types of superconducting qubits depending on the design of the circuit and the parameter that is used to encode the qubit state. So there are a few superconducting qubits such as charge qubits, flux qubits, phase qubits, and transmon qubits. So what do you understand by the word charge qubits? It is basically the use of charge on the capacitor as the qubit state. Now flux qubits, which is also similar to the charge, like having a magnetical flux in the inductor as the qubit state. Now phase qubits. Phase qubit is basically the phase difference between the charge and the flux as the qubit state. Now next we have transmon qubits, which are basically a variant of charge qubit that are less sensitive to charge noise. Next, there are also advantages of superconducting qubits. That's why it's used in quantum computing. So superconducting qubits have several advantages for quantum computing, such as scalability, as they can be fabricated using standard techniques of microelectronics and integrated on a chip. Next, we have controllability, as they can be easily manipulated and measured using microwave pulses and resonators. Coherence. So, what do you understand by the word coherence? So, it basically maintains their quantum state for relatively longer time compared to other qubit technology. Challenges of superconducting qubits. So, superconducting qubits also face some challenges for quantum computing, such as decoherence. So, first you would hear the word decoherence and you wouldn't get like what decoherence is. So, let me explain it to you in simple words. So, decoherence is like a popper in the quantum world. It happens when the delicate quantum information of qubits gets disrupted or lost due to the interaction with the surrounding environment. It's as if the quantum qubits start losing the rhythm because the outside noise interferes in their party, making it challenging to maintain the coherence needed for the quantum computing. So next we have crosstalk, which is also one of the challenges faced by the quantum qubits. So crosstalk is basically in the quantum realm is a bit like different. So it occurs when qubit, which are basically quantum bits, interfere with each other unintentionally, making two quantum whispering secrets. But sometimes their whisper is being overlapped and they end up sharing more than they should. Minimizing crosstalk is crucial in quantum computing to keep each qubit information private and prevent quantum gossip. So next we have error correction. So for everything you do, there should be something which can correct the error which has been made. So error correction is where it comes out. So error correction is in quantum terms is like having a backup plan for quantum hiccups. Quantum computers are sensitive and errors can sneak in. But quantum error correction is a clever strategy to detect and fix these errors, ensuring the reliability of quantum computing. It's like having a quantum spell checker that helps the quantum bits recover from mistakes and maintain the integrity of quantum information. So next, uh, there are a few examples of superconducting quantum computers. There are usually many companies and institutions which have developed and demonstrated superconducting quantum computers using different types and numbers of superconducting qubits. Now there are also a few examples, like for example, Google, IBM, and there are many other companies which are claiming their supremacy over the quantum computing. So let us start from Google, which has claimed to achieve the quantum supremacy. They have an ability to perform a task that is literally impossible for a classical computer using a 53 qubit processor called Sycamore. 53 qubit processor is like a way bigger processor than any classical computers. So next we have IBM, which has launched a cloud-based quantum computing services called IBM Q that allow users to access various quantum processes ranging from 5 to 65 qubits. Next we have Rigetti, which has developed a hybrid quantum classical computers platform called Rigetti, quantum cloud services that combines a 32 qubit processor with the classical computers. So next we have a few applications of superconducting quantum computing. Okay, so superconducting quantum computing has potential application in various domains such as cryptography. So what do you understand by the word cryptography? So it is basically an implementation of quantum key distribution, a secure method for exchanging the encryption keys and quantum algorithms, which makes the hacker impossible to peek into your system, such as Shaw's algorithm, which can factor large number and break some classical encryption schemes. Optimizing. So optimization, it is very important for a computer as it can solve complex problems that involve finding the optimal solution among many possible options such as traveling salesman problem, the knapsack problem, and the quadratic assignment problem. Next, we have machine learning, which is also an application of superconducting quantum qubits. So, machine learning, as it enhances the performance and efficiency of artificial intelligence, techniques such as classification, clustering, regression, and reinforcement learning. So, next we have the conclusion of the video. Uh, so, so basically, in a nutshell, superconductivity is like turning on a magical switch for electricity materials. Exhibiting superconductivity allows the flow of electric current without any resistance, creating a super efficient path in the realm of quantum computing. So, superconductors plays a crucial role in hosting qubits that perform quantum tricks without losing their energy. So, contributing to the potential advancement in the world of quantum information processing, it's the cool, low resistance highway for both classical and quantum electrical adventures. So now superconduction of quantum computing has potential application in various domains such as cryptography, which I have already said. So that's it for the video. Hope you liked the video. Surely drop a like and see you in the next video.
Had all and then most of you, some and now none of you.